Hi everyone, good evening.
Sir, good evening.
Okay, so am I audible?
Yes, sir.
Okay, thank you very much. So that after the weekend we are going to join again. So more two days today and tomorrow there is the class schedule is there. Okay, we are almost going to finish and I'll plan to share that everything tomorrow. By tomorrow after the end of the class, every that PDF will be shared with you. So let's go to the uh, class and a last class we have on that is Friday. We are on the topic of that analytical chemical kinetics, right? So what is the means functions? How does the chemical kinetics affect the analytical chemistry? So evaluation on the basis of chemical kinetics or chemical kinetic methods of analysis. Whatever the things you can name it like that. So how the chemical kinetics or how the technical things are associated with this means mechanism part of the analytical chemistry, how the reaction conducted, what is the rate of reaction, what is the initial rate, and you know that we have discussed about that three different kinds of reaction on the basis of the speed. So that is your very slow reaction. As you just I refreshed your that is some part that is very slow reaction, which is you can say that is the that if we take the example of that rusting of iron, so it is a very slow reaction. You know that you have to wait that is a longer period for this type of a reaction to iron rusting. Okay, that's why it is a slow reaction, and it is very difficult to calculate that. Means in point of view that analytical chemistry, it is very difficult to counter that count and calculate. So that what is the mass of that association of that mass, because we have to wait a longer period of time for the calculation. So that is not possible for also as it is a very slow reaction. If the speed that is more than 1 minute something like that, so that's why we are unable to calculate this type of reactions. So this is not the part of the determinations. Okay. Second thing is this is very slow reaction. Second thing is the very fast reaction. Like if we say the blasting of a cracker, it is the few fraction of seconds it is just happened. So it is very difficult to calculate of this or not, but we can calculate. I'll come to the point that is how we can do this one, but actually that is no, it is not a part of that chemical kinetics to calculate such as the speed of such kind of reactions. Okay, so third reaction is that moderate reactions, so which is feasible to calculate through the chemical kinetics of that reactions. So that's why and in that case we can calculate initial rate, final rate, rate of reactions, and all the things, how the law affected this chemical kinetics of these reactions, everything. Okay, so the now today we'll define that initial rate method. Now see, you in front of you two that two diagrams are there. Just a second. Now you can visible two diagrams in front of you. If you calculate my left hand side, and that is the past that that graph. So it's plotted between the that is product and time along with the product. So time is the lower part, and it is so initial rate of three reactions we have taken, three that is four. We have taken A1, A2, A3, A4. So the solid line which is red in color, that is the things, that is how the reaction is happened. Okay, so if we go to the this part, so it is that the initial rate method is used to determine the concentration of analyte from the experimental rate measurement. So we have to calculate on the experiment basis of rate reactions. We have initial rate of that reaction. So solid curves are the plots of experimentally measured product concentration as the function of time of a 4 standard solution of analyte A. So as I told you, we have taken 4 different types of a solution: A1, A2, A3, A4, and the solid red color lines represent the means plots of experimental measured products concentration as the function for time along with the products. The tangents are drawn in dotted lines, and which is in dotted lines near zero. So if we connected these two, and if we go to the diagram B, so in that case the tangent is a straight line. That means whatever the concentration of A, B, C, sorry, A1, A2, A3, A4, 4 solutions, when you initial rate will be that we can calculate, so the tangent will be in a straight line. So that means, so here the straight line indicates that it is directly proportional so to the concentration. So hence time, as the time will expand, so rate of reaction will be increased. So this is directly proportional. But in the meantime, whatever happened, the initial, we are calculating the initial. So please note it down. So in the chemical reaction, three different things are calculated. One is initial, second is middle, third is that end part. But now the thing is that what I'm going to say, that is the most important thing. As initial part, so concentration is more, means reactant concentration is very high, so rate of reaction will be directly proportional. But after the midpoint, so rate, when the concentration of the reactant will be lower down at reaching the equilibrium point, you can say, so the rate of reactant will be and product will be in the same, and then that what will happen, the rate may not be equal to directly proportional to the rate. So that concentration may not directly equal to the that rate, because it is that, so once that concentration will be decreases, a concentration will be decreases, that means, so that a product rate of product will be, that is automatic product part when be after the equilibrium, product will be, then at the equilibrium, as you know that I told you earlier, equilibrium means, so reactant and a product both are equal. So then from that point, maybe product to reactant on the depending upon the reagent, so we can alter the reaction from product to reactant or reactant to product. Like that, I told you one example of ammonia gas. N2 plus H2 gives rise to NH3. So in this case, at the equilibrium point, so if that you will give that all you, if you want to alter the things, so that means N2H2 gives NH3, then NH3 may give breakdown into the N2 plus H2, or else nitrogen plus hydrogen gives rise to an ammonia. So this is depend upon the catalyst based. So on the after that, rate of reaction will be calculated on the basis of that. So things, if we go next part of this one, so this is the following are advantages of this method. So what is the initial rate methods? If that initial methods if you use, so what type of advantages, what is the that is benefits you will avail by this using this kind of reaction? Number one, since only a small portion of a plot is utilized for measuring the slope, a few data points are enough to make the plot, and there is no need to follow the reaction in the long time or to end. In this way, time saved and the entire product procedure is simplified. So as you know that initial rate, so we'll take 3, 4, 5 points or 6 points. On the basis of that, we can plot the graph. So that's why it is very easy steps and a time consuming process. So that's why it is a simplified process, you can say. It's an advantage. Second is that the reaction obeys pseudo zero order kinetics, as the change in the concentration of the reactants are very small or negligible. So this is obeys pseudo order zero order of kinetics. So you know that zero order and pseudo zero order means, pseudo means false zero order. It looks like zero, but it is actually not zero. Order looks like zero, but it is not actually zero. So that means it is an interesting thing. So pseudo first order, pseudo zero order, pseudo means false. As you know, that is connected with that biological term, that is pseudopodia, which is available in case of amoeba. So that's why it is pseudo means false. So false zero order means it looks like zero order, but it is not zero order. So that pseudo first order, like that, it looks like first order, but it is not first order. So like that, this is the meaning of that one. So behavior. That as the amount of the product formed is small, the reverse reaction virtually does not take place. Now the thing is that here an important point. So the amount of a product is formed is small. So product formation is small because the initial rate of reaction, you are calculating the initial rate of reaction in this part. So only few concentration of that reactant taking part. So only suppose X amount of that reactant taking part and X amount of that product will be formed. It is very small because it is not reached at the midpoint. It is initial. Initial means the concentration is not completely, and the kinetic energy is not completely that is involved in that collision is not faster. So that's why very less amount of that reactant is participated in this kind of reaction. So that's why the product quantity will be less in this form. Next, the complications arising from possible side reaction is avoided. So complication means possible side reaction. I told you that. I told you right now. Possible side of reaction means, what do you mean by possible side? Reactant to product and product to reactant. At the equilibrium state, we don't know that what will the behavior of the reagent. It is, we have to decide that whether it is a promoter or that a poison. If it is a promoter, it will enhance the rate of reaction. Again, that reactant to product will be happen. If it's poison, it will stop the reaction. Then it will be maybe the product to reactant. So either side may be happen. So that's why that is the important point. So, but in initial rate of reaction, it is not happened as we have not reached the equilibrium point. So that's why this thing is not. This is easy one. Okay. Next, if we go to next point, the reaction takes place as a faster rate at the start of the reaction and the results better signal. Okay, now the thing is that, see, it's an initial rate means concentration is high. So that's why the collision will be more. So that means it is the faster rate will be fast, because up to that I told you, up to that means very honestly, very starting period to mid of the time, the reaction rate is faster. Then rate of the reaction will be down. The graph will go down. That's why I told you. So it will directly proportional or inversely proportional, that will decide it. So here directly proportional initial rate when you find out, it is directly proportional because concentration is high. So at the concentration is high, so that means collision will be more. Hence what will happen, that rate of reaction will be good enough to calculate the volume or value. So next, useful for the reactions whose rate constant are too small to be used in the equilibrium methods. So it is another that is benefit points of this one. Okay, now come to that point, fixed time method. So fixed time method means it is an objectives. So the method is the time is fixed, means we have to calculate, suppose the speed of a reaction after 2 minutes or after 1 minute, after 30 seconds, we have to calculate. That time is fixed. So time is fixed. So that's why what is the rate of what is the speed of the rate of the reaction. So in this case, the concentration of a reaction product is measured at a predetermined time from the start of the reaction, as I told you. So the time is fixed, means predetermined time, your time period is fixed. So that's why it is time is mentioned over there. Since del t means change in time, 0 to t1, what is the time period? That is difference, or 5 minutes, 0 minute to 5 minutes, it's 5 minutes of difference of time period. So del t is kept constant. So as you know that time period is fixed here, so time is constant here. The concentration of a product is directly proportional to the change in the concentration of the indicator reaction product. So that means as time is the fixed here, so concentration is directly proportional to the indicator product of the reactions. So because time is fixed, there is no time. We have to find out what is the time is fixed. We have to find out on that time what is the concentration, what is the rate of the reaction. That is the thing. So it is directly depending upon the concentration of the product, is directly dependent on the concentration. So by plotting P versus S, means product versus time, so that the concentration, it will go to that. So that will be product means your initial concentration and product versus that. By plotting the P versus S, the concentration, you will get the straight line with 0 interpret at indicated in the graph. So that means it will give you also if time is fixed, the rate of that is reaction will be a straight line. So it is initial rate is a straight line, and also at the fixed time period, the rate of reaction is also is a straight line. Okay, now the thing is that it will come down. Just a second, please. Okay, so the thing is that if will come down, then variable time methods. Variable time methods means, as you know, that it's a variable term, means time is after 1 minute you have to calculate rate of reaction, after 2 minutes, after 3 minutes, time is changed here. So as per the time is changed, so concentration will be changed. So it's a technically difficult things, because initially the concentration is high, after 1 minute concentration will be low, but product will be increases, so the rate will be whatever the rate, then after next second, next time which is fixed, so that is also concentration will be again less, but time is high. Okay, now the initial rate, what will be the rate of that one, that is most vital period in this case. So now come to the point. So in this method, the time required for the predetermined change in the solution or the formation of the product is measured for a series of analyte concentration. As you know that, as I told you, so as time is variable times are there, after 1 minute you have to calculate, after 3 minutes you have to calculate, after 7 minutes you have to calculate, then what will happen after 1 minute, what will the concentration in the 0 minute, 0 to 1 minute, what will the concentration, 1 to 3 minutes concentration will be decreases, so rate of reaction definitely will be decreases, definitely, it's my perception, but let us see that after that 3 to 7, if the time is third slot is given, again concentration will be decreased, and the time according to time, so rate of reaction will be means affected by the situation. Okay, let's go to that. So the concentration del P is equal to constant, because the product at the part of that we have to find out, and the measured time is T1, T2, T3. So suppose three changing time is there. So the application of this method is given in the 6.4 picture. You check it out, 6.4 picture. So 1 by del T, in the left hand corner there is a initial concentration A0. So A01 dotted line, then A02, A03, A04. All these the plots of the reciprocal of time, means reciprocal inversely proportional for time. So concentration constituent as calibration of the graph, this method is more limited than the fixed time method, as del T does not start from the T10. Okay, so now the thing is that in this case what will happen, so this method is not applicable everywhere. First thing, this method is not applicable everywhere, but sometimes in some very precise reaction, like controlled reactions, so we need to be calculate like your nuclear the chemistry, nuclear method of application. So in that case we have to, that is we have to fix some time calculating things, so that is most important. So it is not applicable in everywhere, but that time is just like the straight line in that case, time and versus the graph will look straight line. Then integration methods. So this is the important method, integration method. So nowadays we are using this integration method. The experimental procedure is similar to that of the differential method, but the values are integrated over the rays, and the integrated values are plotted from the tangent, fixed time and variable time methods. So both methods we can apply here, fixed time and variable time methods. In the tangent method, the formation of the product is integrated over the finite time interval. Del T is equal to T1 minus T2, then log P product, so or log concentration of A is plotted as the function time. So see, that is here that a log p is there and a t time is in second is given there. So initially the graph is in the, we have there is the, okay. So when that this is the integrated things, so product to time, if product, when the product is the highest point, then time will take the highest difference of time. When the product will come down, that means minus 0.5 means just little bit above the minus 0.5, so then time will be come down again up to 3000. So like this the calculation will be there. So product will be increased with along with the time increase plotted methods. Next the thing is with that in the fixed time method, so that is for a fixed concentration of A0 constituent the calibration of the plot. So 1 by del T versus CO for the means concentration 0 for a series of a standard constituent, the calibration graph of the variable time method. So induction period measurement. Now we'll come to the point induction period measurement. This phenomenon was the first observed by the landlord in the reaction between the iodate and the sulfite in an acid medium and called the landlord effect. This method is known as the landlord method. Just a second, some students having the, okay, sorry, you said that 18, 19 lecture slides here. Okay, Mr. Rishikesh, I actually that I was busy in some work. I do have some lots of meetings over there, so unable to share this one. But all of the slides you'll get by tomorrow. My maximum I'll share with the IGNO tomorrow. So IGNO director sir. So then they will provide them. Actually, that I was busy in some meetings, frequent meetings with that one. That's why I'm unable to drop this one. Okay, it definitely will get to don't worry for that one. So the thing is that if in the reaction this method is landlord effect. So A plus B is a slow reaction gives that the product P. So that is that product P plus L, that landlord reagent, as you told you that if will give the C, that is in this reaction if you so see that A plus B is a slow reaction. This is without any kind of a reagent. When a product form and a product again with react with reagent, right? Any reagent, and the first the reaction turns to the fast. That's why I told you earlier when I starting my today is my teaching. So it depends upon the reagent whether the reagent is actively participate in that reaction or not. If it is actively participate, the reaction rate will be faster. As you know that. So if the reagent is a poison, it is not active, means fast active fast, it is slow activator. So that's why the rate of reaction will be slow. So in this case, product, the first reaction it is slow, and but the second reaction with the reagent added to the product, then Y product will be formed. So that is the first reaction. So that is the important point of this. So thing is that now the slow reaction is linked to the fast reaction process through the product P of a slow reaction. So now that I told you that same thing. So in the fast reaction, it is slow reaction, and now the linked with the product. Okay. Now the thing is, since the second reaction is a faster reaction than the first, the product can be detected only when the reagent disappeared completely. Okay. Now the thing is that what will happen? Only that this in this reaction, as you know that reagent what is taking part in the reaction, it may be the catalyst or reagent, whatever things. So they are only the activator, or that is what is slower, poison or promotion, whatever. Sorry, promoter or poison. So they, as per their name, they are acting, right? So if it is a promoter, so only the product you can observe when the actually what is the job of the reagent. Reagent will go away. It's initiate the reactions, it do the reaction, and again it will come back to its own position. When the reagent coming out from that reaction, that it will be behaves as a product over there, because reagent is the initiator. It comes down again to its own position or own form. So that's after that you can get the product. So this is the, it means you have to wait completion of the reagent behavior. So that means disappeared completely. The time elapsed till the appearance of the product is measured of the catalyst concentration, which is directly related to the induction period. So this is what you see the induction. Actually, the induction is a induction period means that during the reaction, how much time is used. Induction period, that is complete reaction from A to B. What are the time slot is will be there? That is the induction period. Now, the thing that experimental procedure involves the measurement of the time elapsed between the addition of the last reaction, either A or B or a catalyst, which starts the slow reaction, and the fast appearance of the signal corresponding to the product. Very low concentration of a catalyst in the range of a microgram and below can be detected by this method. See that this is only that this method can help you to find out only very minutely used amount of that catalyst. So if the catalyst amount is more, so you cannot find out this thing. Okay, so that is the important one. Just a second, please. Okay, now the thing is that then differential reaction rate method. And differential reaction rate method means it is actually it is the integrated rate method, which on the basis of which this is a actual in your exam maybe derivation will come. So this the derivation part is important. So be careful. Actually, as there is means I can explain through the interactive board, right? But this first you have to go through this one. If you'll get the time, so definitely I'll go to the interactive board. How the derivation will be you have to do, but you can understand this one also. An important application of the kinetic method is the determination of a closely related species in a mixture such as the alkaline earth, cations, and organic compounds with the same functional group. See that the thing is that I told you once that is, if you recall, that azeotrophs. I told you that azeotrophs. Okay. So if we see that, if we calculate that thing, what azeotrophs means, I gave an example. So water, ethanol just react with added to the water. Okay. So in ethanol, OH group is there, functional group, and also in water, OH functional group. These two things are contain similar type of group. Okay. So now come to the point here. What is mentioned here? So at an application of the kinetic methods is the determination of a closely related species in a mixture such as alkaline earth cations and organic compounds with the same functional group. So if any alkaline earth cation, alkaline earth means I will say that is group 2 elements. Alkali metal is the group 1 elements, like your lithium, sodium, potassium, then rubidium, cesium, francium, and that is group 2 alkaline earth metal, like your magnesium, potassium, calcium, okay, sorry, magnesium, calcium, etc. Right? So that the thing is that on the basis of that, hello. Okay, so magnesium, calcium, etc. These are the alkaline earth metals. That this if these compounds having the OH group, suppose magnesium hydroxide, and the organic compounds like your, if you tell the alcohol, ethanol or methanol, methanol having the OH group as well as ethanol have sorry that alkaline earth metal like magnesium hydroxide, both having the OH group. Okay, so these two groups if will having the same, if we take the example of a methanol, methyl alcohol, and magnesium hydroxide. So these are having the same functional group. So differential reaction rate method are useful for the determination of two or more species with the common reagent. So that means this kind of compounds can be that means calculated by means of using of this method, differential reaction rate method. So differential reaction rate method is a specific method which is used for the alkaline earth metal as well as organic compound having the similar, that is functional group. So as he told you that if we take the example magnesium hydroxide, OH is the functional group here, OH is there, as well as your, if you take the example methanol, CH3OH, both having the same OH hydroxyl group. So that's why in this compound, in these two compounds having can be that is used for the your what is uh, your differential reaction rate method. So be careful about that. So, for example, consider two species A and B react with a common excess reagent R. Suppose A and B reacts with a common excess reagent R. Means A is react with R and B is react with R. Excess reagent. Be careful. Excess. Any kind of reagent you use, so A is react with the excess similar reagent, and B is also react with the similar reagent, and A suppose give the product P dash and B suppose give the product P double dash. If they are fast order kinetic, suppose let us have fast order kinetic reaction, so that means product rate is directly proportional to the concentration of A and rate is directly proportional to concentration of B, that is the fast order reaction. The sum of the concentration of the species are at the time t is given, so Ct, so concentration at time t, A concentration of A after time t and concentration of B after time t is equal to product minus product after time. So that means A concentration exponential, that is minus KAT, plus B concentration exponential, that's minus KBT, so to the power. Okay, so that means at the sum of the concentration product is given by product PT after time t, product is A naught, means initial concentration of A minus A concentration of A after time t plus concentration of B at the initial time and concentration of B at the after time t. So A concentration 1 minus exponential of the K minus KT plus B concentration 1 minus exponential minus KBT. So this is the mathematical equation. If we come to the sort it out this one again. So this is the mathematical equation. What do you find out? Then it is assumed that no product is formed after the beginning. So let us consider, as you know, that in initial stage there is no product is formed. Let us assume that there is no product is formed. If Ka is greater than Kb, then A is reacted before B. If the concept this potential strength of that A is greater than the potential strength of B, so then what will happen? That A will react faster B because the potential strength is thus. If K by Kb is greater than about 500, about 99% of A is consumed before 1% of B. So as you know that, so A rate of reaction of A is faster. So then that's why 99% of A is consumed before the 1% of B is consumed up. So then A will be the limiting reagent here. If the measurement is made shortly after the mixing, is possible for determined to A with no significant interference from the B by the differential determination. So this is important. You just understand all the things. So it is written very clearly. That thing is that if I told you several times, I told you if concentration and rate of reaction is directly proportional. If the concentration increases, suppose like that, A concentration is high, so after t second, if you go to the t second, A concentration is high, so that means 99% will be consumed, so 1% of B when consumed after time t, right? So this is why the concentration of that particular reactant is more effective than the other things. So now the thing is that then if we come to the logarithmic extrapolation of a method, so if we'll check it out, this one, I'll come to that point, you'll check it out. This graph, you have to check it out. Okay. Now, if you go to the another point, that is activation and inhibition. So this is an important area for activation, and one activation energy is there. And see that let me to explain one fact, that if you come to the point alkyl halide, when alkyl halide, you know that what is that? So polar dissolved with the polar compound dissolved in the polar compound, non-polar compound dissolved in the non-polar compound. These are general perceptions. And polar does not dissolve in the, that is non-polar compound. So that means polar are soluble. Okay, so polar are soluble. So alkyl halide is a polar substance. Alkyl halide is a polar substance. Water is a polar substance. Both are polar. If we take the example of a methyl chloride, it's a polar substance, as well as because the dipole moment is towards the chlorine is there, so a sad pad is moving towards the chlorine, so that means it's a polar substance. And also that your water, you know that water is a polar substance. Though both are polar, they are insoluble. Anyone can say that what is the reason behind this? If any idea do you have, anyone? Don't think that it will be right or wrong, whatever things, that is not the issue. Issue is that if can you say, because I have to explain this activation energy. Okay, that activation energy is an important role. Activation and inhibition. So activation, I have to let me to explain that activation energy. Anyone has any idea that both are polar but they are insoluble? Anyone idea that who can tell me? Okay. If you don't tell me that, if you don't know, that does not issue that. Okay. See that alkyl halide is a polar substance, but water is a polar substance. So in alkyl halide, CX or CX bond, X means halogen, CX carbon and halogen bond, and in water OH bond. That one bond is that oxygen is there H2O. So one oxygen in the middle part, then bent shape, that is a hydrogen, two hydrogens attached. So one OH bond should be breakdown. If that when these two compounds are soluble, they're mixed, these two compounds are mixed, so the amount of energy generated, it is not sufficient to cleave CX bond of alkyl halide. Why? Because, okay, leave it. Why? But the thing is that, so to break down this CX bond, how much amount of energy is required, that is known as your threshold energy. To cleave this bond, CX bond, how much amount of the, that is what is energy is required, that is known as the threshold energy. So threshold energy should be that amount of energy which cleave the bond. So when you added water to this alkyl halide, that what energy is sufficient, generated, what energy is generated, so that energy is not sufficient to overcome this threshold energy. Hence the bond is not cleaved, so they are insoluble. That is the exception. Now the question is that if anything you are mixing up, but they are not, what is the sufficient to break down, and what is the difference amount of energy is there? Suppose I need X amount of energy to cleave the bond, but right now I got Y amount, and Y is lesser than the X. So what is the difference energy is there between X and that top is X, this is Y. We reached at a Y, but we need X amount to cleave this bond. So that's why this difference, I have to overcome this energy gap. This is known as activation energy. Because due to addition of the catalyst, I can overcome this energy. So this is known as the activation energy. So you have to think, so the activation energy is important. Okay. Now the thing is that, okay, Next, measurement of okay, partial rate. Partial rate means categorically you have to find out. Then non-catalytic reaction. Now we'll come to the non-catalytic reaction. So without catalyst, without use of a catalyst. Behavior, that type of reaction. Sulfuric acid is a self-catalytic behavior reagent. As mentioned earlier, kinetic methods based on the on catalyzed reaction are less common. So that is, you know that kinetic energy that this method, kinetic method based on catalyzed reaction are less common. It's less common. Okay, next, this is important. Next, on catalyst reaction can be rendered useful when the selective reagent are employed in conjugation with a sensitive detection method. I told you, very selective method of reagent. As I told you, sulfuric acid, if you want, if you see that sulfuric acid is taking part in the reaction, as well as you know that sulfuric acid is a self that is catalyst, self catalytic, it's a dehydrating reagent. It is a reagent along with a reactant. So as you know that, so this I told you, give you an example. Lots of things are there. Self catalyzed, they are taking part in the reagent, and also they are self reactant as well as the self reagent. So that is why. So this type of a behavior if there, so then what will happen? For example, the selectivity of the complexity reagent complex agent can be controlled by adjusting the pH of the medium in the determination of a metal ions. Suppose at okay, sensitivity can be achieved by the use of a spectrophotometric or spectrofluorescence detection to monitor the reagent that forms the complex with the large molar objectives. The precision of both catalytic and non-catalytic kinetic method depends on the experimental conditions such as pH, ionic strength, temperature, solvent medium, with careful control over these variables. So these are the important areas that non-catalyzed reaction. For that you have to think about that: the pH, ionic strength, temperature, solvent medium, with that 1 to 10% of RSD can be achieved. Automation of the kinetic method and computerized data analysis can improve the relative precision of 1% or less. So these are the things of on catalyzed, for the using of on catalyzed reactions. Okay. Now the common point is, what type of factors influence the rate of reaction? Yes, absolutely. What is the role of temperature? Whether temperature is influence the rate of reaction or that decrease the rate of reactions. What about the pressure? Whether pressure has any role in the rate of reactions, speed of the reactions, pressure has any roles? What is the role of the any kind of a catalyst? So what is the nature of the catalyst? So all these things are that is affect the rate of reaction, speed of the reactions. Okay, if we'll say there is if rumbler is there on the road, your speed of your car or bike will be slow. So that kind of a behavior of this one, that kind of behavior. These are the factors which are responsible for the rate of reactions. What are that? As pointed at earlier, two general types of reaction are associated with the kinetic method: slow reaction, whose half-lives are 10 seconds, half-life are 10 seconds, and longer than the fast reactions are those half-life is less than the 10 seconds. So that means half-lives are 10 seconds and longer, and the fast reactions are half-life which is less than 10 seconds. So slow reaction and a fast reaction, if you say half-life in the sense midpoint. I told you when the equilibrium touch is there, right? Equilibrium position. So if to reach the equilibrium position, if the rate of reaction, if that is, it will take 10 seconds. It is like 10 seconds or more than 10 seconds. So it is known as the slow reaction. If it is less than 10 seconds, it is known as the fast reaction. Then what will happen here? What then factors role? that the rate of a slow reaction can be monitored by direct conventional method. The reaction is started by adding the reactants to suitable vessel and followed by means of performing titration or measuring the physical properties such as potential, diffusion, current, conductance, or absorptions of the pre-selected time intervals. This can be for the slow reaction. The reaction rate is largely influenced by the number of parameters such as temperature. I told you, such as temperature, concentration of the reactants. That is another important fact. Solvent medium, yes, it is acidic medium or basic medium or neutral medium. pH, if pH is acidic, means pH is strength is more than 6 or less than 6 or 2 or 5 or 10, whatever. The ionic strength of the medium, it is ionic. What kind of ionic solution is electrolyte solution you are taken? For this reason, the kinetic reaction are measured under the specific conditions. So for this, that's why we have to measure the kinetic reaction for the specific medium. For this, okay. So for slow reaction with half lives longer than 2 hours, the rate can be adjusted so that their half lives fall within the acceptable range of a slow reaction. This is done by the selecting of more favorable temperature. Okay, more favorable temperature. So temperature is a control settings. Changing the reactant concentration, if you change the reactant concentration, maybe more, maybe less, whatever the process you will take, then the factors will be affected. Changing the solvent medium, if you are taking the acidic medium, if you change to the basic, towards the basic medium, then what will happen? You have to change. Adjusting the ionic strength or pH of the reaction, as these parameters large affect of the reaction rates. So reaction rates will be affected by following methods. Okay, now we'll come to the mathematical basis of kinetic methods. So these are the area on the basis of mathematical derivations. Okay, so check it out right now and just give me a fraction of minutes. Okay, thank you for your patience. So now the thing is that if you go to this particular mathematical basis of the kinetic method, rate law or fast order reactions. Rate law for fast order reactions. So fast order reaction is means order of the reaction is 1. Order of the reaction is 1. So actually that we can find out the order, we can find out the order on the basis of that one just a second. I'm sharing with you one thing. How can you or find out the order of the reaction? Just a second. Give me a second. So please open your that is chat box. Then see that one. It's a technical thing. I just shared with you. That is, please check your chat box. Are you getting? Hello. Can you hear me? Okay. So that means good. So okay, that's fine. That's fine. So thing is that you just note it down this one actually. So for zero order reaction, that minute that is your second inverse. Okay. Molarity second inverse. That means molarity second inverse. Okay. For first order reaction is second inverse. Okay. For second order reaction, it's a liter mole inverse second inverse. That is also zero order reaction is a mole inverse, right? Okay. If you come to the this particular thing for the first order reaction, if you see this one first order reaction, so now the time if will come down, if will come down. So see that this is the first order reaction. This the answer is M, means molarity. Okay, and the see that the time is also in second inverse. It is given in second. So that's why you have to understand whether the reaction from the unit itself. You can understand what is the order of the reactions. whether it is first order, zero order, or second order, whatever it may be. So let's see that rate law for the first order reaction. Let us consider a spontaneous irreversible decomposition of A. So the name is that it is provided. It is provided. It is provided that the spontaneous reaction. It is spontaneous means automatically the reaction will be happened. Spontaneous. Second thing is irreversible means reactant to product is possible, but product to reactant is not possible. Irreversible. Okay. Once the process is completed, maybe it will come down. Maybe again back. So initially, the reactant to product will be happened. Okay. And a decomposition reaction. You have to understand the decomposition means break down into the products. It is split up into the that one reactant will split up into the products. So decomposition reaction A is there. Reactant is A, and it will be spontaneous reaction. It will be irreversible. It will be decomposition. Means every term has a meaning. Every term has a meaning. You have to understand this one. Spontaneous means automatical reactions. Second things, irreversible reaction. Spontaneous irreversible reaction means only the reactant to product, and once process will be completed, then second process will start from the product to reactant. It may be, may not be, that does not matter, but it is only the reactant to product. We have to check it out. And the decomposition breakdown of A to form the product B in equation 6.1. It is written that equation 6.1, whose reaction is a first order in A and a rate is given dA by dt, concentration of dA by dt is equal to minus k dt. This is the what is first order reaction for that one. When the concentration A to A0 means initial concentration, okay, the integration of this reaction from time 0 T0 to time T1 and concentration A to AT. So initially concentration means initially the reaction is not started. By that time time is equal to 0, any T0. So after few 1 minute or as it is a second, few second of time, so that means time is T1. We don't know what is the time slot, but if you will take the T1, then the concentration automatically will be decreases. Means concentration A at the initial stage will be high, and concentration AT is, that is your after time T, it will be, that is somewhat. So here that as the zero order in the time 0 and the difference is there and it first order reaction, so concentration will not be affected. Okay, so that means here dA by concentration of a derivative of A concentration by concentration A is equal to minus k limit 0 to T dt. Evaluation of the integral of the integration of that one, AT by A0 is equal to minus kt. So then finally by taking the exponential of both sides of the equation, we get AT concentration by A after T time T and concentration of A after time 0. So e to the power minus kt. E is equal to here, that what is that? That is what is the exponential of that one. That means the above integration from the rate law gives the concentration A as a function of initial concentration of A, rate constant K after time T. The relationship is depicted in the 6.1 from the reactant and the product. So this is the scenario of this, what is rate law for the first order reactions. Okay, if you go through that, then again time to time you can find out. And also it will come down the here the concentration at the top of the A0, if you left hand top side, so that initial concentration is high, and it will time to time, it will after T, so after some time it will decreases the concentration, and what is the concentration is reflected by the exponential factors. So that means here the rate curve for the first order reactions showing that equal elapsed of times produce equal fractional decrease by the analytical concentration. So you have to go through this graph. Okay, so you will see that if you go to the example, so you got the formula, that is A at concentration of A after time T is equal to concentration of A E E means exponential to the power k minus t. K is equal means constant, that constant, and the t is equal to time. So if the example is given, a solution of initial concentration of 0.0110 m molarity. So initial concentration is given, and that after t second on the first order reaction, so the rate of the constant is equal to k is equal to given 0.0360 second inverse. See that second inverse is given, that is the first order reaction. Calculate the concentration of a reactant after 18.2 seconds. So time you have to find out 18.2 seconds. So a 18.2 is equal to concentration is given 0.010 molarity, and exponential factor is your that is given of a constant, rate constant is given 0.0370 into 18.2 after time t. So that means calculation is 0.0051 molarity. So this is the concentration. Simple method is there. Formula you have to memorize. A at the time t, a concentration A at the time t is equal to a concentration at the time zero period initial, and e to the power minus kt. This is the formula. I will see that this formula you have to, particularly this formula you have to memorize for the calculation. So this is the formula you have to memorize for the mathematical calculation. This is the formula you have to memorize for the mathematical calculation for further for first order reactions. Okay. Then if you go to the rate law for the second order of reaction, so let's second order reaction means if you find out that second order reaction, it is that you can say for the second order reaction, so liter mole inverse second inverse unit should be there. See that is important, because sometimes the question will ask that what is the order of the reaction. So order of the reaction means that from that if you see the your constant, that rate constant, if the rate constant unit, if you see that if it is liter mole inverse and second inverse, then this will be second order reactions. So on the basis of that you can calculate also. Okay, now the thing is that let us now consider a reaction in which one more of analyte A react with one more of a reagent R to give single product P. Let this occurs in a single step and also be irreversible. So A and A is a reactant, and it is reagent is B, sorry, R. So here the gives rise to product P. If the rate, it depends upon two things. So that's why it is the second order reaction. Why it is second order reaction? So it is depend upon A as well as R to get the product P. So product P will be formed when A and R will together will work. So that's two things are important. If the rate of is proportional to the concentration of E is concentration of A as well as concentration of R, so the rate law is equal. See, as I told you, two factors are responsible for these reactions. Age, concentration of A is responsible, concentration of B is responsible. Sorry, R is responsible. R is you have taken as the reagent. So if one thing is not present, this reaction will not happen. This reaction will not take place. That's why both concentration are responsible for the formation of the product P. Hence, it's a second order reaction. Two things are responsible. So if one thing will not be there, so first thing will not give the product if it is the second order reactions. So the concentration of two things are important. Two things are important for the second order reactions. Okay. So if the rate is proportional to the concentration of A and R, the rate law is derivatives difference d of concentration A by dt is equal to K concentration of A and concentration of R. So this is the thing. So this rate is first order with respect to the A as well as respect to R, but second order overall. As you know that this is the first order reaction, but it is respect to A as well as R, both are there, both concentration is responsible, so it is a second order reaction. You have to calculate on the basis of that one. So yes. Okay. So rate equation for irreversible process. See that this is the rate equation and is the important one. If you have to see, that is the it is given there. What I mentioned over there, so that chart is given here, means formula is your common unit for the rate constant. See, this from this unit you have to understand what is that. These things is important. You have to note it down, this one. Please take the screenshot of this one. All of you, please take the screenshot of this one. This is the formula which is essential for all of you to calculate the mathematical numericals. So check the concentration, check the formula, this one, and take the screenshot. I'll provide you, but for time right now, you can take the screenshot of this one. Once screenshot that taken, you just tell me. Then I'll go to bottom part of this one. Have you taken the screenshot?
Yes, sir.
Okay, that's fine. So I'll go to the bottom part of this one. You have to also take the screenshot. So 3, then 3 to this. Okay. This is, you have to take the screenshot of this one also. Once you have taken, please inform me. Okay, fine. Okay, by using the C, that what I earlier told you, that unit for the rate constant, if it is mole decimeter cube second inverse, so that means it is the zero order reaction. You see that k is equal to x by t. So on the basis of that, you can check it out. It is the a single reactant or reactant at a equal concentration, right? So on the basis of that, you have to get the formula of this one. So here reactant at unequal initial concentrations. So on the basis of that, order is given, and also rate of reactions, that unit is given. On the basis of that, formula is also given. On the in the that examination, that this type of question will come on the basis of these formulas. So please. Now the thing is that estimation based on the kinetic and acid base equilibrium studies. So that okay, just give me a second. I am okay. So now the thing is that uh, Mr. Yes, I have already shared with you. Okay, just let me check it out. Dipendu. Okay, Dipendu. Okay.
Yes, sir. I'm sharing.
Okay, that's fine. Or someone is asking your phone number.
Yes, sir. Yes, sir. I'm
Okay,
sharing.
that's fine. I think so. He's if that anyone is, he actually that yes is making one WhatsApp group, right? So if you have a you people having no issues, you can share your number, that you'll be in touch in that analytical chemistry and all the things. This is my personal view. If you are interested, you can. If you're not interested, so not an issue. Okay. Now the thing is that estimation based on the kinetic and acid base equilibrium studies. Actually, all of you received. Tell me, I am from I am from that side.
No, sir, I'm asking that it's a all India basis class or ki,
Yeah, all India
आपके
basis
लिए?
class. It is a all
Oh,
India
that's right,
basis
that's
class.
right,
No,
that's
no,
right.
no. The all India basis class.
Thank you, sir, thank
So
you.
only directors are will be there, might be. So that is not the issue. He is the sole means having the sole power, because IGNOU Bhubaneswar is organizing these classes, and this is all India class.
Right, sir, I'm from KIIT Study Center. So you're asking.
Okay. Oh, you are from KIT Study Center.
Sir.
Okay, no
Yes,
problem.
sir.
No problem.
Yes, sir, yes, sir.
You can be touch with me, or that is no problem. Okay.
Okay, thank you, sir.
No problem. So estimation based on the kinetic and acid base equilibrium studies, reaction are seldom irreversible, and we have to take into the reverse reaction whenever necessary. I told you. So estimation based on the kinetic and acid base equilibrium studies means reaction are seldom irreversible, and we have to take into the reverse reaction whenever necessary. If you remember that I told you, you will stand on the 11th floor of the that one building and throw that tied one stone in the one end of the thread, and another you hold on and throw that all the that thread with along with that stone to the bottom part of this from the building. So okay, Sumitra Pradhan is from the kit. Okay, no problem, Sumitra. Sumitra, hello.
Yes, sir.
Okay, no problem. That you are from Kids Studies. That is, it is the all India class. Okay, don't worry for that one. So
Uh,
if you have any issues, you can toss with me. I just we have that. That is not the issue, right? This is all India class,
Okay, sir.
and your means your BBSR is conducting this class. So all India class. Okay, no problem.
Okay, sir.
So that's I told you that day. So thing is that when you threw all the means that stone along with the that thread to the, you hold one end of that thread, and all the rest part of the thread along with the stone you throw from the top to the bottom. What will happen? So that stone will reach at the bottom part. Then it is possible to, you have to pull up. In between, it is not possible for you. So that is irreversible reaction. That is irreversible reaction. If that is, if we throw the stone, if we suppose it is 10 meters 20 meters of height of that building, and you hold the threads 1 meter, that in the, there is a stopper after every 1 meter. If you throw 1 meter, then you can pull from that 1 meter to position at you are there. It is possible. That is reversible reaction. So reversible reaction and irreversible reaction you have to understand. So here the fact is reaction are seldom irreversible. Means if it is acid base reaction, so it is irreversible. Means one step will completed, one process will fully completed, then you can come back. Acid base reaction will be completed, then product will be there. Suppose if you say that you have hydrochloric acid, strong acid, and strong base, sodium hydroxide. So strong base and strong acid. So that reaction will complete, and it will give that you the sodium chloride along with the water as the product. Fully completed. In the mid of the reaction, you cannot alter the reactions. It is not possible. Acid base reaction always irreversible reaction. Final product will be there. Then you can again that sodium chloride you can you can make dissociate that one again. You can react with other product. Then you will find out the hydrochloric acid as well as sodium hydroxide. That doesn't matter. Matter is that if in between there is question, can you alter the reaction from midpoint? The answer is no. We cannot alter the reaction from the midpoint. The reaction once it will be completed. So be careful. Acid base reaction means it cannot be altered from the middle point. It is irreversible reaction. It is only alter. It only can be react. Only can be revert back. So after completion of full reactions, when reaction step will completed fully, then it is possible. But until unless the reaction step is not completed, you cannot alter from the middle part of this reaction. This is irreversible reactions. And we have to take into the reverse reaction whenever necessary. For such reaction, the rate is the difference between the forward rate and the reverse rate. So if these things happen, so then what will happen? Those two things are different things. So on the basis of that, you can see this is the procedures. The reaction scheme for a compound A and B with common reagent is as follows. A plus R gives rise P dash plus HCl. B plus R gives rise P double dash plus HCl. So A is one reactant, B is another reactant. In both cases, reagent are same. Product is A is different. From A is different along with the HCl. Product is B from the B is different. B is P double dash and is along with the HCl. The chloride ion concentration was measured as a function of the time a sample solution of the 10 ml containing A plus B plus solvent was reacted with an excess reagent of R. The molar concentration of the chloride ions where B, this is the ionic that is analytical method, ionic solution analytical method. On the basis of that, you can calculate these things. Okay, next. Then catalyzed reaction. So we have touched with the non-catalyzed reaction. Now we'll go to the catalyzed reactions. Okay. Many of the reactions are catalyzed by inorganic anions and cations. Many of the reactions are catalyzed by inorganic, that is this is inorganic anions and cations by enzyme and are widely used for the detection of a variety of biological and biochemical species. So this is another thing that is. We will now see how the rate laws can be reduced. Relatively simple algebraic relationship for enzyme catalyzed reaction and used for the analytical purpose. Enzyme catalyzed reaction. See, that is in the below there is a that pictorial representation. So enzyme is E and plus substrate S. So this is the kinetic gives the ES enzyme substrate complex. Again, that kinetic energy will be there. Then the product and enzyme will be left out from the product. Okay, so enzyme here is the catalyst. As you know that we are sometimes that is see that if you go to the doctor, my digestion system is not properly working, so I indigestion problem is frequently I'm feeling that if I take the that is the very common food or very hygienic food or very means that is what is cryogenic food or whatever maybe you can say it will take, then what will happen? So if digestion is not proper, doctor write down some enzymes. So do you know that what is the enzyme is a type of a catalyst? It is just initiate, it stimulate your functions. It stimulates the functions. Suppose if you take you know that sometimes the sports person undergoes the doping test. Okay, so what happened that sometimes you have gone through the several types of news that this sports person is catching due to that taking in doping. So they are banned for the several years of that taking part in the sports event. So what is that? So they usually take some kind of non-advisable that medicines or you can say drugs, which is stimulate the muscle functions, heartbeats. Then what will happen when it stimulates? You have to do something. So that's why they use that energy, that stimulating energy in the running format or any kind of events. So that is an that is an activator. You can say it's a type of enzyme, but it is not good. For medical point of view, it is not good. Okay. Unnaturally, we are giving the strength to our muscles. Okay. The thing is that what I'm going to say, the work of enzyme is very specific. Very specific. It will say that will lipase, it will biological knowledge, if you have something, or in this case chemical means that is your biomolecules, and also that is your polymer or chemistry day-to-day life. If you have any kind of a knowledge, so enzyme gives particular works. Suppose if you take the lipase, so it is a type of a digestive enzyme. Okay, so that it helps to digest the stimulate the digestive functions. But thing is that if will take some kind of a enzyme which is enhance the function of your liver or your pancreas, so that will different work. So thing is that very particular function of that that enzymes is there. So enzyme is a type of catalyst. So here the enzyme acts on the substrates like that. If my means that any kind of food you have taken, suppose I am telling that any kind of food it is not properly digested, so I am using that digestive enzyme. That means enzyme is the digestive enzyme what have you taken, but substrate is the what you have eaten, right? So it will act on that one, then it will form a complex of ES will help to digest that molecules, your substrate, then product will be formed, and the enzyme will go away from that after completion of its duty. Okay, so that is the function of enzyme. In okay, so in which the enzyme E reacts reversibly to form the enzyme substrate complex. This complex decomposes irreversible to form the product P and generate type enzymes. What I told you. Since the reaction involves two steps, the rate law for this mechanism assume one of the two forms depending upon the relative rates of the reaction. If the second step is considerably slower than the first step, the second step determines the overall rate of the reaction and is termed as the rate determining step. If the two steps are comparable rate, then assume the steady state condition. We will now see how these two processes are seen. That these two things, first enzyme reacts with the substrate, then one complex is formed, then second from that complex that product will be formed. So two steps, enzyme substrate form, and complex is formed. This is one step. Second step is substrate to product. So now the fact is whether the step one, enzyme substrate and enzyme substrate complex which is formed, it is slower, or enzyme substrate to product, it is slower. As you know that our motto has to find out the product, so we have to consider both the steps. So first step is slower or second step is slower. First condition. Second condition, that what is the rate of that first step, and if it is equivalent to the second step, so both steps will be considered. In the first procedure, what I said, enzyme and substrate complex is formed, and so from substrate complex product is formed. If that first step is the slower, then that will be the point, that will be the order which determine the product. If second step is the slower, then second step is the vital that point to calculate the rate of reaction. So that means which step is the slower, then that is the vital step to calculate the rate of reactions. First thing. Second thing, if the both rate is equal or equivalent, so that means both steps are responsible. If one step is responsible, means slower step is responsible, that order is one. If both steps are considerable equivalent rate of speed, or the speed of the reaction or rate of the reaction, then both steps are responsible, hence order of the reaction is two. You have to understand what is happening over there. you should you should minutely follow. So several times I told you, as you know, that analytical chemistry is a chemistry gives the practical knowledge to the your near and dear. Those are coming up. So these steps will give you the practical knowledge. If I am a successor or predecessor of these things, successor or predecessor of these things, so if your generation is coming, new generation, you are going to say something to our newer generation. So that means you have to keep the correct information. Okay, for that analysis should be there. Wrong information put you in the some kind of a wrong state. Okay. Now, rate determination by the rate complex formation. This is, see, that is the things. So acid base, you say that how the rate will be determined. I told you on the mathematical basis, this is the procedure. You will go through this one and determine the rate. So as I have told you already, that it determines a substrate or that is enzyme. On the basis of that, what is that? You have to go through this one. Okay, now check it out. This particular graph diagram is in front of you, and then I'll comment. So, go through this one. Okay. See that in this particular kinetic energy, the detection system you can use. What kind of a detection system you can use? Optical method you can use, UV, visible spectrometry, or a fluorescence spectrometry, NMR, ESR. These are the things you can use in the optical methods. Electrochemical methods like potentiometry, conductometry, polarography, amperometry, then radiochemical methods and thermometric methods. All methods can be used for the determination in these steps. So this is an important area of study. Then we'll come to the if application. So estimation of based on the acid base equilibrium. So this is another reaction, means your what is a titration titranic method is there. So you can apply here. So then it will come to the point that end part of this particular chapter. So define, explain the following terms: order of the reaction, differential methods, integral methods, half-life. Okay, distinguish between first order, second order reactions. What type of reactions are called fast reaction? How they can measure? Okay, everything we have discussed. So on the basis of that, you have to check it out. Anyone has any questions over this chemical analysis of method? Okay, no problem. Okay, that's fine. Okay, this area is finished. Let's wait. Just be second. Okay, that actually I shared with the formula that is. Okay, sorry. That my mic was muted. So okay, no problem. Yes. So thing is that just a wait. So that yes, Mr. Gaurav Kumar has raised her hand. Okay, no problem. Okay, just a second. That Dibyendu has a question. So it's not question exactly. We'll try the numerical problem. If faced any problem, then we'll inform you. Very good. So you try. I'll explain you that one. Okay, just a second. Just a second. You just all of you set your question. I'll one by one. I'll go. That yes, from Jabalpur. So he's RC Jabalpur. He asked a question that, sir, the screenshot shared by you formula give one example. Okay, that's fine. Okay, I'm coming to your point. Next, Alexandra is there. Yes, Raut, make it. Yeah, he has made the. Actually, Alexandra, I told you one thing. So, yes, has made a WhatsApp group. Okay, so that thing is that if you are interested, all of you interested, you join. There is no, we are not forcing to anyone else. From my side, I just clear one thing. If you are interested, you join in that group. So we can I can give you the, I am in that group also. I can share whatever the questions you have, you will ask later on, or what is your problem, I can that assure you and sort it out your problems. So that he has okay, so many people's uh, okay, so many people have shared their number. We please that do it accordingly. So yeah, that okay, now come to the point of that yes question. Yes, that is actually the thing I'm going to say. See, sometimes I'm going to say you that very you don't have to work much more. This is completely we have that I have shared with the formula and order of the reactions. Okay, that formula and thing is that unit also. Okay, so suppose one question is given. Suppose one question is given. Here that see that heading is given. Yes, are you getting me, Mr. Yes? Are you getting me? All of you, listen. That he has a very good question. Okay, yes, are you getting me? I am not. Your audio, your mic is off. Yes, you can you unmute your mic? Hello. Okay, no problem. So that thing is that I said you the all the things. Okay. So I'm telling you, I'll explain that tomorrow I'll go to the numerical segment because I'll use that whiteboard. I'll explain one two numericals, how to calculate with that one. Today is not possible because it's time to going to over, and also that I have to use the whiteboard and all the things. Okay. So thing is that I explain all the things. What is that? Formula is given. Order of the reaction. Yes, yes. So order of the reaction is given. Okay, suppose, see that what is mentioned here, it's mentioned in the top part of this one, a single reactant or reactants at equal concentration. Suppose the question is like this. Suppose a question is like this. A compound A having the concentration X M molarity. Okay. A reactant having the concentration X means 0.10 molarity. Suppose let us take 0.10 molarity at the initial period. Okay. So, but after 5 seconds, it undergoes the first order reactions. After 5 seconds, it has a concentration. We don't know what is the concentration. After 5 seconds, time is given here. Initial concentration is given and order of the reaction is given. Order of the reaction is first order, right? Note it down. Initial concentration is 0.01 m molarity. Got the point?
Yes, sir.
Okay. Now the thing is that time is given 5 seconds. Time is given, note the time is given 5 seconds. It is the given part in the question. And the question is that question wants to know what is the concentration after 5 seconds. We have to find out the concentration after 5 seconds. Got the point? It is the first order reaction. So go to the first order reaction. So in this case, first order, in the left hand side, there is a first order reaction. See, here is a single concentration. 0.01 or 10 molarity, a single concentration. So the reaction part is a single, okay, single part, and is the first order reaction is only one formula is there. Ka 1 by T ln A naught by A naught minus X. Got the point? Here, A naught is equal to concentration at initial concentration. And A minus X naught is equal to, you have to find out the value of X here. Once X you find out, so after some time means you have to subtract this X amount from the A naught, initial amount. So that is the final after 5. So we can do that. Yes, your mobile is ringing. Okay, no problem. So tomorrow we'll do the calculation by how you'll use this one on the whiteboard. I'll explain all the things, numerical part. This is the important one.
Okay, sir.
Right?
Okay.
Okay. So the thing is that tomorrow I'll discuss that this numerical one more unit may be there. So I'll help you in that case. And also I'll try to distribute all the PDF notes regarding this unit, basic analytic chemistry, because next your that is suppose Wednesday onwards you are having that practical, I think so, practical chemistry and all the things. Am I right? So second unit will be there perhaps.
Yes, sir. So MCH-02 is there.
Yes, 02 is there. 02 is that, what is that there in 02? It is practical based.
That is separation method.
Okay, that's fine. So thing is that then we'll come across this one. If you have any question, you can ask me about that one. Okay. So 634. What is on? Okay. That Dibendu. Sorry. Yes. You are. Are you making the WhatsApp group? Yes.
Yes, sir.
Okay. That so many students they have put the WhatsApp number. Their number.
Sir, they have already shared.
Okay.
I will create it.
Okay, so please, so in that group you just added, and please, this is the All India group, so no personal
Sir,
messages.
only sir, study related or
Yes, that's my personal request from my side. Okay, no problem.
Yes.
That is no personal.
Sure, sir. Sure, sir.
Okay, that's fine. So if you have any question at any time, you can drop me the message. Okay, I'll help you out. Okay. Thing is that all of you got that Alexandra is there. Perhaps she was telling that some Alexander is there, na? Alexander. Okay. Some that is study material also provided by the means in there. Is it available in that? I don't think so. It just came out. Assignment is there.
Yes, sir. Assignment already available in the internet.
Okay, that's fine. Means your session MCH 1001 assignment is available.
Yes, sir.
Where is it available? Can you tell me?
No, sir, I will share it on WhatsApp group.
So can you do
All
it
the
right
all
now?
the yes, sir. Just
Can you do it right now, please?
yes, sir. Just a minute.
Okay, thank you very much. Okay, that's fine. I got it.
Yes, sir.
Okay, that's fine.
For 2024 batch, July 2020 session, it is also.
When you have to submit this one?
Sir, I think
Submission
before
Sir, before 31st.
June,
31st
July.
January.
March.
March. Okay. March. Okay, that is fine. So if you have any kind of see that already, perhaps I have all the things we have mentioned here that is like that I have seen this one. Explain potentiometric analysis and conductometric analysis. Okay, if I will go to some questions with suitable example, differentiate between accuracy and precision. Okay, then what is mean by sampling and how is the sampling dissolved? Okay, what is the source of a determinant for errors? As far as my knowledge, everything is there. Okay, what I taught you. What are the ways in which percentage in liquid sample can be expressed? Okay, what is the formula for average deviation? It's there. What is the specific criteria for selection of location for the sampling? Okay, so it is there. Most of the things. Okay, you just go through any issues anywhere else you will find out. So MCS2 only. Okay, it's only 10 questions is there, na?
Yes, sir. 10
Okay.
question.
Okay. If you have any
100
issues,
marks.
you can okay. You can communicate with me. I'll help you. So definitely. That's fine.
Okay, sir. Okay, sir.
Okay. So thank you for your cooperation and help me out. So from this case, okay. So anybody's have any questions?
No, sir.
Okay, that's fine. Sumitra, are you enrolled in the KIT, right?
Yes, sir.
So have you gone through all the classes or you have that messed up with any class?
Sir, I attend previous 2 classes.
Okay. Because you are started from the 17th or you are absent.
Yes,
Okay,
sir.
fine. Okay, no problem. So, okay, that's fine. And thank you very much to all of you. So I am leaving the class for today. Okay. So tomorrow we have the same time and do the last class. So I'll try to share all the things and numerical will be done. So this your what is that? Chemical kinetics numerical will be done tomorrow. So please be allowed for that one with pen and paper. Thank you very much.
Thank you,
Thank
sir.
you, sir.